In this video, I'll cover how to make a DOAS system in OpenStudio 3.2.0. A DOAS is a dedicated outdoor air system, essentially an HVAC system that's exclusively used for bringing in outside air with minimal or no conditioning capabilities attached to it. The first thing you want to do is make sure that you have a model that is running with no severe errors and has construction schedules, loads, and so on applied to it. You can see my model here. If I render it by by space type, you can see that I've got several different space types applied. I called this one a living space, a first bedroom, a secondary bedroom, a bathroom, and a kitchen. So these give different ventilation conditions that we'll be dealing with here. Rendering by thermal zone, you can see I've got these space types grouped into two thermal zones, a bedroom wing and a living wing separately. Before we get started, there are a couple things we want to check and make sure we have set up properly. You'll want to have a weather file attached. I've got the Austin weather file already connected here. I want to bring in my design days because I'll be auto-sizing some of these pieces of equipment. So I've imported those. We want to make sure that we have outside air and infiltration set up properly. To see how to do these, I've got a separate video on ventilation and infiltration. But for our purposes here, you can see that I've got ASHRAE 62 standards set up for the bathroom, first bedroom, a second bedroom, a kitchen, and living space. And then I've got infiltration objects set for each of the spaces as well. Next, we want to make sure that we start by going to System Simulation Settings and then Simulation Control. Open that up. You want to turn on the zone sizing calculation, the system sizing, and you might as well go ahead and turn on the plant sizing, although I presently have no plant in the model and you probably don't either. You may eventually have that in there. That way you don't forget to go back and turn it on. I prefer not to run the simulation for sizing periods, but to run it for the weather file run period. So I'm going to save my model with a new name now. And get started building my DOAS system. So I'll go to my HVAC tab over here. It'll take it just a moment to load. And presently I've got no HVAC at all in the model. I'm going to add an HVAC system with the green plus over here and scroll down to empty air loop and add that to model. Click on this middle line, and then I'll see over here on the right hand side that it gives me the opportunity to edit. I'm going to name this so I recognize it. I'll just call it 1 because there could be several in a model, but we'll only have 1 in ours. Oops. So keeping that selected, we want to make several adjustments here in the settings over here on the right. We're going to leave it on auto size. We're going to adjust our type of load to size on to ventilation requirement because we're providing ventilation air, and that's our key factor we want to size for. We're going to change the central heating maximum system airflow ratio to 1, meaning it can bring in 100% outdoor air. Since we're not doing any preheating or pre-cooling, which would be possible and sometimes often is used on this type of system, but since we're not doing that, we don't need to worry about any of these temperatures down here. We want to make sure that 100% outdoor air and cooling and 100% outdoor air and heating are both set to yes. And then we want to make sure the system outdoor air method shows zone sum. All right, from there, we can put in our outdoor air system. So we're going to go to Library and browse for Air Loop HVAC outdoor air system. So I went too far. There we go. I'm going to drag that over onto one of my supply nodes over on the left, and it pops it in there. I can click on that, and now it's showing over here in my Edit tab my outdoor air system. We're still going to leave this on auto size. We'll let the maximum rate be auto sized as well. And we don't want an economizer set up. And we also want to make sure that it's not showing lockout here, so no lockout under lockout type. Next, we're going to go to Library, and I'm going to browse for heat exchanger air-to-air sensible and latent. There it is. And I want to select the ERV HX model and drag it over onto the node above the outdoor air system here. If I click on that, this is my ERV. The default values are actually pretty good for what we're looking for here. So we'll leave it on auto size. All the effectiveness values are fine. The heat exchanger type won't make a lot of difference, but plate is fine. There's no supply air outlet temperature control. And on economizer lockout, that one's not going to affect us because we've already said there's no lockout on the outdoor air system. And we don't have an economizer anyway. Next, we're going to go to Library. You're going to browse for fan. Fan constant volume up here. And drag that. I'm also going to drop it onto one of my supply side nodes over here. The efficiency, pressure rise are fine. The maximum flow rate will be auto-sized. The motor efficiency, we're going to leave those on the defaults as well. I'm going to go back to my Library tab again. I'm going to scroll down to the set point managers, of which there are quite a large variety. A number of these would work in this particular situation. Oops. I'm going to choose Set Point Manager Outdoor Air Reset. I'm going to drag the object Outdoor Air Temp Reset onto this node here, the one on the right-hand side of the supply side of the system. If I need to, I can edit that over here, but there's no need to. I'm going to leave it on the default settings as well. All right, I'm going to go back to Library one more time and browse for air terminal, single duct, constant volume, no reheat. Right here. I'll grab that, drop it onto my demand side node, click on it. It's the diffuser. It's on auto size as well. And then lastly, I'm going to go back to my model, and up near the top, I'll find thermal zone. And I'll bring the thermal zones that this system will serve over here. So first of all, thermal zone 1, I'll drop it on here. And I have another zone that this ought to be serving. I can drop it down here, and it'll automatically reproduce the same diffuser that I had on the first one. So what do I have here? I have an air loop. I can see that I've got the outdoor air controller up here. The ERV is attached to that. Outside air is going to be coming in through this node. It'll be exhausted back through that node. Once it comes in, it goes through the controller, gets blown by a fan, which is controlled by the set point manager, and then delivered to the space. And this air will then be tempered because the heat exchanger, the ERV, is going to exchange the majority of the heat and moisture conditions between the inside air and outside air. So we're not just bringing in outside air directly untempered, we're bringing it in already partially conditioned, and in a very efficient way because it's using the heat and moisture in the indoor air to temper that outside air. All right, so we also want to be able to make sure that we have everything operating correctly. Sometimes with this type of system, it can be a little hard to tell if it's operating right, or if it's operating at all even, and where it's operating. So I'm going to turn on a couple of variables over here on the Output Variables tab that will help me determine that. So the first one I want to look for is zone infiltration air change rate. It's going to be all the way down under Z. There are many that I could pick, but I like this one because it's going to output in air changes per hour and make it easily intelligible what we're getting here. And we'll be able to compare it to our settings for infiltration in terms of air changes per hour. There's another one here, zone ventilation standard density volume flow rate, standard density volume flow rate. Let me browse down and find that. Here we go. I'm going to turn that one on. I'll leave it on hourly. Now I've been having trouble with this particular variable. It's worked sometimes and hasn't worked at other times. So in case that one doesn't actually end up reporting, for me, I'm going to also select air system outdoor air mass flow rate. That way I'll have it something else reporting to make sure that I can tell whether my outdoor air is running, even if I can't get the volume flow rate. All right, I'm going to save my model. I'm going to come over to Measures. I've got my OpenStudio results turned on. That'll be handy. So let me now run a simulation. And we'll wait a few moments while that processes, and we'll look at our results. All right, the simulation is complete. I'm going to open my results in DView here. I'll go ahead and display them in IP units. And let's see what we've got. So first of all, it's already displaying the air system outdoor mass flow rate. And it's telling me that I'm getting 0.236 pounds per second of airflow as a result of my outdoor air specifications here. That's about right. That's an unusual unit, not one we're generally used to thinking in, but if you convert that, that's going to be in the neighborhood of, I think it ends up being around 200 CFM or a little bit below. So it's right about the right value. Here it's not reporting my zone ventilation design standard density volume flow rate. If that's working for you, then it should be showing up down here, and that'll show you the value in CFM if you're working in IP, or cubic meters per second if you're working in SI. I want to also check my infiltration air change rate as well to make sure that the infiltration is behaving as expected. Turn that off. And you can see I had infiltration set at about 0.027 air changes per hour. And you can see that ends up being right about the average of the air change rate. What happens here is that Energy Plus fluctuates. It looks at the wind speed and the orientation of the building, and then estimates based on those factors how much infiltration is actually happening at any given time under those natural conditions. So it varies some, but you can see it varies within the range from about 0.26 to generally about 0.286, with one anomaly here where it got much higher, probably during a really high wind condition. Okay, so we have our dedicated outdoor air system set up. The next step will be to put in HVAC, which I'll cover in a separate video. So thank you very much for watching.